Today, I want to talk a little bit about exploring Elixir project recompilation. And I will start with just a few words about myself. So I'm a software developer and I live in a beautiful country of Estonia. And I worked with Ruby, with JavaScript/TypeScript. And for the last 4 years or thereabouts, I'm working with Elixir. I work at Mindvalley. We are building personal growth educational platform. And yes, as a hobby, I also play in theater. On the right is my picture from one of our plays. And without further ado, let's jump into straight into the topic. And I want to start with describing what this talk is actually about. So this talk came as sort of a reflection. I've been working on our application and I started questioning, okay, when I change certain files, why do some of the files get recompiled? Why some other files don't get recompiled? What triggers those recompilations? And today I want to share some of my discoveries. But I actually want to start it with a question like, why bother with it at all, with some rationale? Because these days, Elixir compiler is actually really good. And we don't have scenarios when there are, for example, hundreds of files that are getting recompiled. So currently, our situation is really good already. And when I asked this question of why bother to myself, I came up with more or less 3 answers. And the first one is feedback time. Every file that gets added to recompilation, it increases the feedback time. It increases the time between when you do some change in the code and when you see the result of that. And that time is just idle. And when this time is increased, I think it makes, at least me, it makes a little bit less productive, a little bit less happy, a little bit more tired by the end of the day. So, and this is where I think even a couple of files can make a difference. The second thing that I thought is that when you make your code easily digestible for compiler, it actually makes it more digestible for developer as well. It works kind of both ways. And the third one is that by mingling, by looking into these things, I think it gives you a new perspective of how you can look at your code. Now, I want to start with the very top level. What is actually happening when we run mix.compile or mix.compile.all? Elixir gathers a list of compilers for different file extensions like HEX, EX, EARL, LEX, what have you. And then it runs each of these compilers to compile those files, right? And today I will focus specifically on the .ex and won't be covering anything else. Now, when it comes to .ex, it will compose a list of files that need to recompile. Sometimes it is an entire application, right? If our project became stale, for example, we changed config or we updated a dependency, then the entire project needs to recompile. Then after this list is composed, these files will be compiled, and then some other stuff will happen like protocols consolidation and other things. And finally, a new manifest file will be built. And what I'm interested in is how was this list of files composed. And to talk about that, I first need to reiterate and talk a little bit about dependencies in Elixir. Now, I'm not talking about mixed dependencies, I'm talking about dependencies between modules. And I will reiterate a great article from Dashbit that covers this, how it all works. There are generally 3 types of dependencies in Elixir. First one is called the runtime dependency, and this is happening if there are 2 modules A and B, and module A calls some function from module B. This is a runtime dependency. Second one is export dependency. It's when module A either imports a function from B or pattern matches a struct from B. And the third one is the compile dependency, and this covers other cases, for example, if module A uses a macro from B or implements a behavior that is defined in B, or some other scenarios, for example, if module A calls a function from B inside of a module body, but not inside of a function. But how do these affect recompilation? Of course, the most relaxed one is the runtime dependency. If module B changes, then module A doesn't need to recompile, only module B gets recompiled. With export dependencies, if module B is recompiled or changed, then module A also needs to recompile, but only if we added a function or removed the function to module B, or we changed the struct that was defined in the module B. And finally, the most strict one is the compile dependency, and it means that if module B changed, then module A will have to recompile. Now, there is an important asterisk to this schema or to this behavior, and it is that if we have three modules, A, B, and C, and module B has a runtime dependency on C, and module A has a compile dependency on B, then if we change C, then module B won't need to recompile, but module A will have to recompile. And this chain of dependencies can be as long as or as short as a developer did it, right? There can be 5 modules in between E and A, but as long as there is a compile dependency on the edge, module will get recompiled, which in turn might cause recompilations in modules that depend on A, right? Now, this schema starts looking interesting if we apply it to some different file structures that can happen in the Elixir application. So let's talk about cycles. What is a cycle? A cycle is when two modules reference each other in any way. So we have A that references B and B references A, for example, like this. We have two modules, both have just two functions, and module A calls a function from module B, and module B calls a function from module A. This creates a cycle between these two modules, and they are now depending on each other. And what's interesting about these dependencies is that they are actually not equal. You can have runtime dependency in one direction and the compile time dependency in another direction. And that can create some interesting behavior. And in addition to that, these cycles can be longer than just two files. We can have A depends on B, on C, on D, on E, and then E depends back on A, and this creates a longer cycle. Well, now let's take a look at the example of these uneven dependencies between modules. Here we have 4 modules: comment, user, GitHub, and implementation. First one is the comment, and it's just an ecto schema. And it has one function foo that returns 1, but also it defines an ecto schema where it tells that, okay, I am belonging to a user. Second one is user, which is kind of a mirror. It has many comments, and it also has a function auth that just returns an atom. Finally, we have a client for GitHub. And this client consists of 2 modules. One is called GitHub itself, and it does 2 things. One is it defines a callback called auth, so it defines a behavior. And second thing it does is it implements this behavior right away, basically, by defining a function that it delegates to an implementation. Finally, implementation just implements a behavior defined in GitHub and also has a function auth where it just calls user. Now, what happens if we change comment and change return value of foo from 1 to 2 and run a compile? So here's what's going to happen. 2 files will get recompiled, and the very first one that will get recompiled is actually GitHub implementation and not a comment. And second one will be a comment. Now, the first time I saw this, I was kind of like this. And especially because this was in a bigger application, it wasn't just 4 modules, it was a larger amount of them, right? And it seemed like my change caused the recompilation in a completely different part of the code. And to investigate that, we need a tool called mixxref. Now, mixxref is a great tool that allows us to investigate how actually modules relate to each other, how they depend on each other. And specifically, we're going to use the mixxref graph that builds a graph of dependencies. And you can feed it with an argument sync, give it a file name, and it will tell you all the files that depend on the given file and the way they depend. On the bottom is the output, but it's kind of a text output. And xref also allows us to make an image. And I think it will be better if we look at it like that. So this is the same graph, but just built from a dot file generated by mixxref. And to track down those recompilation behavior, what we can do is actually follow the arrows, but just follow them backwards. We can start with the user, but there is an arrow that leads from comment to a user, and this tells us that comment depends on a user, right? Because comment in its schema, it belongs to a user, therefore it has a dependency on that. So we can follow that arrow, and this is a runtime dependency, so it doesn't trigger any recompilation. We can follow it further. We have now user that depends on the comment because user has many comments in its schema. And it's also a runtime dependency, so also no recompilation. Then we are going to GitHub implementation. Implementation calls a function from a user, and it makes a runtime dependency. Again, no recompilation. Follow further from implementation to GitHub. Now, GitHub just proxies a call to an implementation, right? It doesn't do anything else. And this is that dependency. But finally, at the end of the day, we arrive on this compile dependency. Implementation depends on GitHub in compile because it implements a behavior from GitHub. And this creates a compile dependency. And through this long chain of dependencies, we end up in implementation that gets recompiled. How to resolve it? Very simple, by just extracting the behavior. So behavior, here I extracted behavior into another module that defines a callback, and both GitHub and GitHub implementation now implement that behavior. And if we rebuild the graph now, it would look something like this. And now, again, if we do exactly the same thing and just follow the arrows backwards, from user to comment runtime, from comment to user runtime, from user to implementation runtime, and finally from GitHub to implementation runtime. And here's where the chain of arrows end. Now, both GitHub and implementation have a compile dependency on behavior, but in this case, behavior doesn't have any dependencies of itself. And now if we change comment, just comment will have to recompile. So this is how cycles can create an interesting and seemingly unrelated recompilations. But there is another thing that can do similar thing. And this is what I call the double dependencies. It's not an official name by any means, but that's just the name that I thought describes it. And it basically tells us that there can be more than one way to build a road between two files. And again, just an example. We have three modules. One is called a source, and it defines two functions. Another one is called shared, and it does, again, two things. It defines a macro using, and inside of that macro, it defines a function foo, which delegates a call to source. And on top of that, in the shared module itself, it also defines a function bar, which delegates a call to a source. And finally, we have the third module, destination, that doesn't do anything, but it uses shared module. That's all it does. It doesn't have anything else. And again, if we build a graph for that, this graph starts to look quite interesting. Now, we can see there are three arrows in this case. And by just looking at the graph, it seems like the arrow between source and shared and the arrow between shared and destination are kind of connected, but not exactly. So let's take a look at let's take a look at each of these arrows separately. Now, the arrow number one that declares the dependency between shared the source and source is actually this def bar. It's not dev foo, it's a dev bar because it is in the module body of shared. And this is a runtime dependency. The arrow number 2 is because of dev foo, because when we use a macro in destination, we kind of inject function foo into a module destination and creating this runtime dependency between destination and the source. And finally, just by the fact that we are using shared, we are using that macro, we are expanding it, we are introducing a compile dependency between destination. So even though these are kind of a different branches of the code, we are having this chain of dependencies. And to break it, it's exactly the same thing. We can just split the macro part from the runtime part. I extracted the function bar into a proxy, and everything else remains the same. And now the graph looks very different. I actually here built 2 graphs. One is all the files that depend on source, and another graph is all the files that destination depends on. And as you can see, the arrow number 1 is present in both of these graphs, and that's because by using shared, we are adding a function foo, so destination has a runtime dependency on a source. Destination also has a compile dependency on shared, but shared doesn't have any dependencies of its own anymore. Even though it has a macro, it has a dependency inside of a macro. It doesn't matter because it becomes a dependency of destination. And finally, there is a proxy that has a runtime dependency on source. So now if we change a comment, then, or not a comment, sorry, if we change source, then destination won't need to recompile. So what does it tell us? And by looking at these 2 examples, I think for me, the idea that came up for me was that it's nice to separate runtime code from the compile time code. Compile time code doesn't necessarily create a problem, but it can create a lot of problems when it's mixed with the runtime code. And of course, there are possible exceptions. For example, runtime code doesn't have dependencies. It's just a bunch of functions that, I don't know, sum a number or something like that. Or if runtime code dependencies, there are runtime dependencies, but they don't change. For example, it's a dependency on Ecto or Phoenix or some library. However, if it's dependency on the module from within your application, then it's kind of a red flag, and because you will need to check, okay, does this module that I'm depend on have any dependencies of its own? Because again, coming back to the beginning, we can have the chain of dependencies, it can be very long or it can be very short. Now, finally, I want to give a really quick note about export dependencies. And export dependencies, at least in my experience, are a lot less problematic than compile dependencies. And they are much less likely to cause a cascade recompilation. To illustrate that simple example, we have 3 modules, A, B, and C. A defines a struct and the function. B also defines a struct, and in the function, it pattern matches on A. And C just pattern matches on B. So the chain of dependencies is on the right. And now if we add a function to A or remove a function or change a struct, then B will recompile, but C won't be affected by it because it needs B to add a function by itself in order to trigger an export recompilation. So that's about export dependencies. And now I want to give a few words about how it affected our application, the application I've been working on. Now, when I looked into those 2 issues that I described in the beginning, because they are both based on real examples, and I extracted macro code into its own file and behaviors into its own files, then when I changed some file in our system, our recompilation time reduced from roughly 4 seconds to about half a second. And the amount of recompiled files changed from 42 to too, which is, I think, quite a big deal. At least it was for me. And this is comes back to the very first point that it decreased the feedback time. So now there is a shorter time between when I wrote a test and when I saw the result. But the next thing is that it didn't affect the entire app recompilation. If I do a forced recompilation, then it would still take more or less the same amount of time. And it only makes sense because we didn't change the amount of code that needs to recompile, right? The amount of code stayed the same. It's just, it's at least it could even increase because we had to add new modules, right? So the code base became a little bit bigger. But full application gets recompiled less frequently. And to dig into that, I think we'll need to look at leveraging the parallel compiler in Elixir and look at the wait times, what files wait for what, and if we can make it more parallel. And the final point here is that every app is, of course, different. This was our experience. This is what we encountered in our system, but your system can be different. It's very individual. Now, I want to put these things into a context of Phoenix application specifically. And the first point here is that cycles are unavoidable, because if we are working with Phoenix, there's a high chance we are working with Ecto, and if we're working with Ecto, we're working with database, and then we have relations. So as long as we have belongs to, has many, has one, many to many, what have you, you will have cycles. And these cycles can be longer than just two modules. However, Phoenix with its context, or generally the idea from Ecto that, hey, let's split our schemas from our business logic, it kind of implicitly or automatically helps with both export dependencies and cycles. Why? Because, for example, with cycles, even though they are unavoidable when it comes to schemas, all these schemas can be encapsulated in a sense. They can be put in their own bubble where it's like they live there, they reference each other in all the ways, but the entry points are limited and they are not affected by those cycles that much. And with export dependencies, again, if we have context or some other modules that don't follow the context idea generally, then these business logic files, they have a lot less dependencies. They have a lot less files that depend on them, and which makes it easier to investigate and untangle. And also, Elixir improves compilation all the time. For example, export dependencies were introduced in 1.11, and it made a big deal. It reduced the compilation quite noticeably. Then in 1.13, semantic recompilation was introduced. And another example is live dashboard, where it used to add the compile dependency for a router, and which I noticed personally when I changed some schema in one of our applications. Router was recompiled, and it was because live dashboard used to introduce a compile dependency. It doesn't do that anymore, so now router is not recompiled, which is a nice thing. Now, a few words about tooling. I would say there is mixxref, and mixxref is the bread and butter of investigating issues. It can build graphs, it can build graph of dependencies that for a certain file. It can tell all the files that depend on given file. It's very, very flexible and very, very versatile. And also it has a nice flag that's called format cycles. And this flag gives an overview on cycles. It shows all the cycles that exist in the application. And we can also use it for CI. In 1.13, there is a new argument called fail above, which you can configure in the way that makes sense for your application. You can say, okay, I don't want cycles longer than, I don't know, 3, 5, something. Or I do want them, but only within schemas. You can also do check on compile dependencies, transient compile dependencies. All that can be configured in CI, and then CI will do a lot of job of making sure that we are not having weird dependencies. Finally, there is a mixed trace that allows us more thorough check of a specific file. If we give it a file, it will go line by line and show what each of those lines does, which one introduces a dependency, what type of the dependency is it, and so on. And to wrap things up, first of all, I think that these days it can be easier to prevent cascade recompilation than to fix it. And both Elixir and Phoenix helps us with that. Elixir by its tooling and by its design, and Phoenix by its ideas and generally ideas. For example, like I said earlier, mixxref, we can configure all types of check in the CI, and they will ensure that we don't shoot ourselves in the foot accidentally. But then, if there is an app, there's probably a legacy. There's probably some code that exists already. And within that code, there could be some low-hanging fruits to fix. To find them, first thing I think we can focus on is the compile dependencies. We can, again, use xref, go through each of the compile dependencies we have one by one, and ask a question. Why is it here? Is it necessary? Is it introducing some transient dependencies? Or is it free? Is it just a macro from Phoenix? Or is it something that can cause problems? And another good thing that's good to check is cycles. We can, again, print all those cycles and ask ourselves, hey, I have a cycle right here. Do I need it? Is it necessary? If I break it, will it make it better or will it make it worse? It depends. It may be yes, maybe no, maybe nothing needs to change, or maybe it does. And this brings us to the final point, and at the very same time, the first point. I think that if we look at our system through these lenses, from this perspective, it kind of gives us another perspective on the app. On top of the ideas of design, on top of the ideas of best practices, linters, and all that stuff. By just looking at it, we can look from the perspective of dependencies. Hey, how does my dependency graph look like? Which I think makes us better as a developers. At least I found myself in a better position after jumping on the stuff. And that's all, folks. Thank you very much for coming. Thank you for listening, and hope you enjoyed it.
Thank you, Anton. Do we have questions here in the audience? Do I have the mic for the audience? Okay, let me do, I have one question, but also if you have a questions on, there's a question on Hoover. I'm gonna just say that. So, what do you think a reasonable number of cycles would be to fail with the fail above flag?
That's a good question, and I think it depends. It depends a lot on your business model or on your business domain, because sometimes you may need a longer cycle to shortcut between your entities. Like, I think in general, the number would be, I don't know, 5 or 6, but there can be much longer cycles than that, and they can be fine. Again, it depends on the domain.
Thank you. Do you have a question here in the audience? Okay, I'll ask my question then. I was just curious. You mentioned that some weird things happen when you mix the dependence types between the files. I don't know. Do you know any weird example, or you just saw some weird things? Like, what would be these weird things?
Yeah, by weird things I meant that that I touch a file somewhere in the system, And I look at the files that get recompiled, and it's like, boom, completely different place. It looks like I'm touching one thing, but then someone in another city gets affected. And I was like, what?
Okay, I see. Well, do you have any questions here? I think. Okay, thank you a lot. And yeah, thank you for being here for the talk. Thank you.
Thank you very much.